Hello students, welcome to the next video of Unit 5 Data Science. In this video we are going to discuss about the strings and dates with R. So just take a brief recap about the previous video. In previous video we have discussed about the data structures where we have discussed about the vectors, lists, data frames and factors, and conclude this previous video as data transformation, some basic examples and basic functions. Now in this video we are going to cover two topics, that is strings and date. Both are the important when we do data analytics. So strings is any continuous character value is called a string. So any coded value, that is a pair of either single quote or double quote, can be treated as a string in our programming. This string stores the character data type vectors. When we discuss in vectors, there is a character that stores the string. So basically character type is string in R programming. So character vectors are required to create using the C function. There is another function named paste. It is also used to unite strings mutually. So let's take an example. First example is using this C function where we have put a string. Programmer must apply double quotes in maximum case. Here we close the string with double quote and then make a comma to separate this, and second portion of this string is added as single quotes are used for including within the string. Here this code is within the single quote, and between this single quote we have put one double quote just to check what happened with this double quote. First part of this phrase is double quoted and last part is single quoted. When we execute this string, the C functions, the result is like the first output is programmer must apply double quotes in maximum case. So let's see the program. We have close our double quotes here. So this part can be taken as first part, and this single quotes are used for the including as shown here, and this is the not showing by the single quoted, this is showing by also a double quote. So whatever we use, either single quote or double quote, both are the same in terms of R programming. Let's use the another function paste. Here we create paste with the C function and we pass to two value red and green. Outside this bracket we also use mango. So basically paste functions merge both the strings like red mango, green mango. So as a result we see red mango and green mango, both the elements are just mapped with the mango. And see another example with the separator. Paste red green mango. Now we have used a property separator. Here we apply separator as dash or minus. So this separator will replace its by default separator, that is space, and here now red mango become red dash mango and green mango as green dash mango. So use of separator is demonstrated here. Next is how to create a string. So basically in R, character is held or a string can held 1 byte integer in a memory for each variable. So there are four different types of string, four different ways to enter a string. The first one is using single code. We can assign directly with the single code in a variable. Here we create a variable and we assign value Shyam with the single codes. Another way is by assigning value with the double code. Here term Rahul is assigned with the double quotes in variable e. Third one is using conversion from the existing vector as dot character. As dot character is a function that typecast another vector into character vector. Fourth one is using the C function that is already we seen in previous example. When we display the value of these similar values can be displayed. The result of D is Shyam printed as double code. Second one as it is with the double code. In third one, when we convert the numeric vector or integer vector into the character, then each vector can be treated as a character or a string element rather than numeric. And fourth one is using C function. Now some basic string functions that are used. Here we are using the first one to convert number in a string. To convert the number into a string, we use toString function. Here in variable g, we have stored square of sequence 1 to 7 and that too converted into the string. So as far result is concerned, it stores all the element as a single string value, because whatever stored in G is now converted into a string. So whole the series of numbers, the whole the vector of numbers is now stored as a string. Second one is to change string in uppercase. We have pass a string changes to uppercase with the function to uppercase into string variable, and when we print this string variable we find the whole string is now converted into uppercase. Third one is to convert the string or to change the string in lowercase. Here we also pass a string with the function to lower into a variable str, that is string variable, and we print this string and we find the whole string is converted into the lowercase. All the lower cases are placed. Some more functions just to find out how I can identify the string length, how many characters are there. To check this, we have a function nchar, number of characters in a string. When we display this, we found total 21 numbers in this string. Next is to fetch piece of string. If we want to display some portion of a string rather than complete string, then we can use a substring function of string. This is the variable that we pass with substring function. Starting pointer from where we want to display and last pointer up to we want to display. So here 0 to 7 letters are displayed. So let's check 1, 2, 3, 4, 5, 6, 7. Starting from 0 to 7 letters are displayed here. Next is split the string at any word or any character. In example, we are using a W just to demonstrate, but if this letter can be repeated many times, so when it appears it will be breaked by this function. To breaking or to splitting the string, we use string split function, where we pass a string and the word which we want to split. So we also take in the same string, and when we use to display the results, we find that changes to low. After this lower there exists a w. This w is lapsed and it can break into two parts. First part is changes to low and second part is r case. So this is the results that split this string into two parts. If we use w, we use o instead of w, then it can break like changes t, then l, then wer were cases. It can break into three parts if we use o instead of w. Next is substring replacement. Suppose we want to replace some word, then in this case we use a sub function. Here we are going to replace lower with the small letters in existing string. So when we see the results, changes to, instead of lower, small letters are replaced. So instead of lower, now we have a small letters in the same string. Going to the next function, when we want to concatenate two strings or we want to join two strings, we can use paste. Here st1 is concatenated with existing string and a new string that is mentioned with the separator null means space. When we print this st1, then we find out the changes to lowercase. This is the string value, previous string's value, and now added value is string functions. Now if we want to count character appeared in a string, then we can use a grep function. For example, we have a string that contains a three values: regular, expressions, and examples of our language. Now we are going to find out how many times x appeared in a string value with the value is logically false. This means do not display the value. When we print the x, it displays 2 and 3, means second and third portion of the string having the ex. Okay, looking for the same example, let's change this value from false to true. Now this will display the string where ex exists. So in this we identify the second element as expression and third element as example of our languages. Both are having ex in the string. Next is grep that returns a logical vector. Suppose we put grep that is ex exists in string, it will return as true or false. For first value, that is regular, no ex exists, so it shows false. But for the rest of the two, that is second and third string, it is presented, hence it's displayed true. So these are the some basic string functions. Now we cover date. R provides a broad range of capabilities to deal with the times and date class. So basically there are the three types of date and time classes that arrive with the basic R programming. These are, first one is POSIX CT. that provides dates and times in classical all manner. Here city means calendar times. When we use this type of POSIX city, we can use a simple function that is system dot time that displays date, current dates, current system date along with current time and your time standard. So IST represented here as Indian Standard Time. Then next is POSIX LT that stores date and time values as a list of components like hours, minutes, seconds, months, etc. Making it easy to extract these parts, we just use it as date as and time with respect to different listing components. Third one is date. This date class is finally used in such cases where programmers do not bother about the time of day, which time it is taken. We don't bother about the time or timestamps. We just need a date value. To check this out, we have an example. We create a variable now date, and we have converted the now city value means this value into date. So it is just like a typecasting, and we find the value that is today's date, 10th April 2020. So date class will help to deal with the date only. In this date, we don't bother about the timings. Let's have some date functions. To display system date, we use a date function. When we display the date, it shows like Friday, April 10, time is 13:26. That is uh, afternoon 1 p.m. 13 minutes. When we are going to display system date and time, we use system dot time. Here we can find out the date along with the time and the standards. To display the system date only, when we don't bother about the time, then we can use sys dot date function and we get only the today's or current system date. To check the classes of mentioned function here, we also apply the class to the date function. We found it is a character type. So basically date function returns the character value. The system time can returns the POSIX city and POSIX t value, while the system dot date returns pure date data types. To understand the date codes, to make understanding properly with the components of dates, we have some codes that are used. Percentage D is used as day of month. What is the date of that month? Percentage is M used for the month in decimal number. Then percentage B used for the month abbreviated, like for April it is written as APR. Percentage B is used for the full month name April, APRIL. Percentage Y is used to display the year in 2-digit small y, and percentage capital Y is used to display year in 4-digit. We have to remember one thing: the default date format is YYYY means year, MM means month, and DD means date. So in previous examples, we display the date accordingly to the this default format. Now, how we can convert strings to date? We have checked that date function by default returning the character value. That means it returns the string. Suppose we have a list of strings that contains a date. How we convert this into a date? So here we quote an example. Here we create a variable where we pass string dates and we display as dot date. We are just nothing. We are going to convert this dates. Let's see the results. When we convert this, the individual identity can be treated as the simple dates. To convert date from customized string format. So this is the by default format. We have a year, then month, then day. Now next we want to convert this with the default format. Suppose we have day, month, year, and we want to convert this string into the date. Then we have to use as dot date function, like the value of a string, then format. We have to define its format. First we have to return day, so we use percentage d. Then we use month, then percentage of month, and finally at last we use year. So one thing we must have to remember here, if we mention anything wrong, means month more than 12, day more than 31, in that case this string cannot be converted into proper date. It will be displayed as null value. So when we convert this string into date, we have 2019 year, one month, that is January, and date is 7. So 7/1/2019 become 2019 1/7. Next, create date by merging data. If we have a different vectors, how we can create dates to merge them? Here we take a variable year that stores the different years. Then we have month, and finally we have days. To convert POSIX object, we use ISO date function. So ISO date function stores year equals to year, month equal to mo, and day equal as day. When we display this output, we found this value. But what about this value? This is not passed on. Remember, I told you convert to POSIX object form. Means it is not defined in the string. That's why it takes a random default value. Now, how we can truncate the unused time data? Because there is no time mentioned in this data. So we can convert it as date ISO date, then the value. Means this whole data can be again formatted into a date as dot date function, like this. Now we have only dates instead of complete POSIX form. So thank you for the watching this video.